Hokie dokie. Welcome to this week's quick quiz lesson. In this video, we'll be covering some of the big ideas. In 1524's quiz 7 in 15 minutes or less. Let's get started.
Composition of functions.
So in this problem, they give us a function f, they give us a function g, and they're asking us to find the composite function g of f of x. And so we know that g of x is equal to 2 to the x. So if we wanted to find g of, say, 4, all we would do is plug in 4 to the exponent and calculate that. But in this case, they're not asking us to plug in a number, they're asking us to plug in an entire function, f of x. So what we'll do is plug in the entire function, f of x, into the function g in place of where the x was. And that's it. So we're just looking for the answer that matches this most closely, and that's option C. And in this problem, they want us to find f of g of x. And so if we know f of x, then f of g of x will just be this function g plugged in place of where the x was. And so in this case, we just plug in the 9 over 2 raised to the x in place of where the x was, and we get option B. And in this problem, we will actually use the same exact process. There's just one extra step at the end, and that'll be plugging in a t value. And so they're asking us to find f of t, which is just g of h of t. So the function g is the fourth root of x. But we don't want to plug in x, we want to plug in h of t. And h of t is equal to e to the negative t over 2. And that's it. So that is g of h of t, but they also told us that g of h of t was equal to f of t. And so really, this is just f of t. So then if they're asking us to find f of 2, we'll plug in 2 wherever we saw t. So then if we start simplifying, negative 2 over 2 is just negative 1. E to the negative 1 is just 1 over e. And the fourth root of 1 over e can be rewritten as the fourth root of 1 over the fourth root of e. But the fourth root of 1 is just 1. And so all we're left with is 1 over the fourth root of e. So A is our answer. All right, one more example here. They're also asking you for g of h of t. And so if g of x is e to the x to the fourth, then g of h of t is just e to the square root of t to the fourth. But keep in mind, g of h of t was also equal to f of t. So what we really just found is f of t. And if they want us to find f of 2, we'll plug in 2 wherever we see t. So now let's think about simplifying this. If we were to rewrite the square root of 2 as 2 raised to some exponent, that would be 2 to the 1/2. And then if we have a 1/2 next to a 4 in the exponent spot, what we do is multiply those two values. 1/2 times 4 is just 2, so then we have 2 squared, which is 4. And so all we're left with is e to the 4th, and we're done.
Intro to chain rule.
Alright, in this problem, all we have to do is take the derivative of the first function. The derivative of r to the 5th is just 5r to the 4th. And then we take the derivative of the second function. The derivative of 4 to the t is 4 to the t times the natural log of 4. And then we just multiply these two together. And we're done. But let's talk about why this works out. So when we took the derivative of this function x with respect to r, what we found was dx over dr. Likewise, when we found the derivative of r with respect to t for the second function, we found dr over dt. And then when we multiplied these, what happened is the dr's canceled, and what we were left with was just dx over dt, and that's what they were looking for. So we'll just do one more example here. Again, we just take the first derivative. Derivative of e to the r is just e to the r. Take the derivative of the second function. ln of v gives us 1 over v, and then we multiply these two together, and that gives us a. An important thing to remember with this problem is you want to see the r and the v. You want to see the two different variables. For instance, the answer would not be c because they have both v's for both derivatives, but we want to see the different variables r and v, or whatever the two variables might be in our answer. And so this problem is a nice extension of the last one because we'll start the same way. We'll take the derivative of both functions. X cubed gives us 3x squared, and then ln of w gives us 1 over w. And so because we found the derivative of f with respect to x, or df over dx, and the derivative of x with respect to w, and then we multiplied them, that leaves us with df over dw. So we found what they're asking for. Now we just need to plug in w equals 2. So we could plug in 2 here, but we can't plug in 2 here for x. So what do? Well, x is equal to ln of w. So what we do is, in place of x, we plug in ln of w. So we substitute something in that is in terms of w in place of x. And now that allows us to plug in 2 here and here. So when we do that, we get this. 3 times 1/2 is just 3/2. And then if we have ln of 2 all squared, we can just rewrite that as ln squared of 2. And so really all they've done is put the 3 up top, 2 on the bottom, and left the ln squared of 2 on top. And we're done.
Chain rule.
So let's say we want to take the derivative of some function y. In other words, we want to find y prime. But let's say the function y is some composite function. In other words, it has outside layers and inside layers. This is where the chain rule comes in. Chain rule is just the process of taking a derivative of a function that has multiple layers to it. So the way we start is by taking the derivative of the outside layer, f prime, while leaving the inside layer the exact same. And then all we do is just multiply by the derivative of the inside layer, g prime of x, and we're done. And so in its simplest form, this is the chain rule.
So let's do a few examples.
In this problem, we are given the function c of q equals e to the 1 over q squared, and they're just asking us to find c prime. This uses the chain rule. How do we know? We have 2 layers to this function. We have e to the something, which is like e to the x, and then we have 1 over q squared. E to the x is our outside function, and 1 over q squared is our inside function. So what we need to do is find the derivative of both of these functions. Starting with the outside layer, e to the x has a derivative of e to the x. But we actually didn't have x in the exponent. We originally had 1 over q squared. And so again, when we take the derivative of the outside function, we leave the inside function the same. We leave it alone. So now, let's take the derivative of the inside function. Whenever we see q or a variable in the denominator, and we're trying to take the derivative, we want to rewrite that function so that it's in the form q to the a, or x to the a. We want to rewrite it like this so then we can use the power rule to take its derivative. We bring out the -2, leave the q, and subtract the exponent by 1, so we have -2q to the -3rd. If we rewrite this, we can throw the q to the 3rd back in the denominator with a positive exponent. Now all we'll do is multiply these 2 derivatives we found, and we should be done. So my best suggestion is to look at the answer that you have and try to match some of the terms that you have to the answer choices. And you can use that to help eliminate options as well. We must see this e to the 1 over q squared in our answer. We do not see that here, here, or here. Therefore, that leaves A to be our answer. We see -2, we see q to the 3rd, and of course we see our e term. And so A is our answer. Same deal here. We're given this function. We want to find its derivative. We want to ask ourselves, what's the inside function and what's the outside function? The outside function is the ln of q squared, or ln of x, however you want to see it. The inside function is the q squared. So now we just find their derivatives. Ln of x is 1 over x. But again, we didn't have x, we actually had q squared. And so we take the derivative of the ln, but we leave q squared as it is. And then we take the derivative of q squared. Using the power rule, we just get 2 times q. So now we multiply these two, we get this. And if we simplified this, we'd get 2q over q squared, cancel out a q on top and bottom, and we're left with 2 over q. So now I'll just run through as many chain rule examples as I can. With this function, the outer layer is 3 to the something. The inside layer is 1 over square root of p. The derivative of 3 to the something is like 3 to the x. So we'd have 3 to the x times the natural log of 3. And so really in place of x, we actually have 1 over square root of p. Now we take the derivative of 1 over square root of p. In order to do so, we need to rewrite the square root of p as p to the 1/2, but then 1 over p to the 1/2 is the same as p to the -1/2. So now we can take its derivative by bringing out the -1/2, leaving the p, and subtracting the exponent by 1. -1/2 minus 1 gives us -3/2. Remember our trick from last week? If we have a fraction and we're subtracting it by 1, my trick is to take the top number minus the bottom number and leave it over the bottom number. In other words, -3/2. So we have our 2 derivatives, and now we just multiply these together. An important tip is this. If we see 3 raised to some exponent in our original function, we must see 3 raised to that same exact exponent in our derivative. And so if we don't see 3 to the 1 over square root of p in our answer, it's not correct. So
here we do not see it, here we don't see it, here we do not see it.
That leaves us with a automatically. So let's double check all the other pieces. ln of 3, ln of 3, negative 1/2, we have a negative and we have a 2 in the bottom. That's good enough. And if we see p to the negative 3 over 2, that is equivalent to p to the positive 3 over 2 in the denominator. So A is our answer. In this problem, they give us a function and they ask us to find f prime at 0.1. So we need to find the derivative first using chain rule and then plug in 0.1 at the end. For a function like this, it'll always help to rewrite it as ln of x all to the 3rd power. In doing this, we can more easily see our layers, our inside layer and our outside layer. Our inside layer is the ln of x, and our outer layer is that exponent of 3, so it's like we have x cubed. So we take the derivative of both these layers to get 3x squared and 1 over x respectively, but again, we didn't have x on the inside. What we really had was ln of x. And so when we brought down the 3 and subtracted 1 to get 2, we just left that ln of x the same. So now we multiply these two derivatives. So we get this, and because this is our derivative, now we just plug in 0.1 wherever we see x. So when we calculate this, we get 159.06, which is approximately 159. And we're done. In this problem, we're finding the derivative of u. In order to do so, it might help to rewrite u as ln of 2 to the negative s all to the negative 1. So if we take care of the outside layer, we bring out the negative 1, we leave all the inside stuff the same, and we subtract 1 from the exponent to get negative 2. Then we work our way to the next inside layer, and that is ln of 2 to the negative s. So the derivative of ln of something is 1 over that something. The next layer is 2 to the negative s. That's an exponential function, so its derivative is 2 to the negative s times ln of 2. And then there's one final layer, and then the final layer is really just that negative s. So when we think about negative s, we want to find its derivative. The derivative of negative s is just like the derivative of negative x, and that is negative 1. So what we do is multiply everything we have by negative 1, and this is our derivative. So we have a negative 1 times a negative 1. That's just positive 1, so those will just cancel. We have 1 over 2 to the negative s times 2 to the negative s. We could think of this as 1 over x times x. That's just going to be 1 because we're taking something and multiplying it by its reciprocal or inverse. So in other words, these cancel each other out. So now what they've done here is a little evil. They've used properties of logs to bring this exponent out in front. So what we get is negative s times ln of 2. And then this ln of 2 gets carried down. So if we have all of this to the negative 2, that's the same as throwing all of that to the second power, but in the denominator. So just making that negative exponent positive. So then we square the denominator. Negative s squared is just s squared, because if we take negative s times negative s, we get positive s squared. And then ln of 2 squared is basically ln of 2 times ln of 2. And so if we already have an ln of 2 on top, we can cancel an ln of 2 out on the top and bottom. So what we're left with is an s squared and an ln of 2 in the denominator. So that is option B. And we're done. Alright, in this problem, we're given v. We want to find v prime. The outside function is e to the something, so we want to leave that term exactly how it was. The next layer is something to the 4th. So when we take the derivative of something to the 4th, we get 4 times that something to the 3rd. And so we just leave the 2 to the negative z on the inside of those parentheses. And then our next inside layer is the 2 to the negative z. That's an exponential function, so its derivative is 2 to the negative z times ln of 2. And then our very last layer is that negative z. Any negative variable has a derivative of just negative 1. And this is our derivative. So again, we want to see that same exact e term that was in the original function in our derivative. So which answer has that? Not this one, but then C and D do. And so if we eliminate options A and B, we move on to another term. If we want to find ln of 2 in our answer, we see that here, but not here. Therefore, C must be our answer answer, and I'll leave it at that. If you want to see why all these terms match to all these terms, I recommend watching my other video on this exact problem. But for now, process of elimination will do. C is our answer, and we're done. Alrighty, if you enjoyed this video, please hit the like button. If you want to stay updated for more quick quiz lessons this semester, go ahead and subscribe. If you want to connect with me or other students in the same course as you, or ask me questions or whatever else, join the Discord. That's all for this week's quick quiz lesson. I hope you learned something. See you next time. Bye-bye.